Imagine a world where every time you wanted to write a letter, you had to pack away your calculator, close your books, turn off the lights, and sit in a bare room just to focus on that one thing. This was the reality of early computers. In the 1960s and 70s, mainframes and early personal computers forced users to close one program in order to open another. If you wanted to perform a calculation while writing a report, you had to save your work, exit the editor, enter the calculator program, return results, and then switch back, hoping nothing crashed along the way. The reason was simple: these computers knew only how to run a single task at a time. The hardware and software of the day had no mechanism to let multiple processes share the same resources safely, fairly, or efficiently. Productivity was throttled by the machine's inability to divide its attention, and user frustration reigned supreme. Enter the pioneers of operating system design. Recognizing that CPUs sat idle while waiting for input or disk operations, thinkers at places like MIT, Bell Labs, and IBM developed the idea of time sharing. But the true game changer was preemptive multitasking, an operating system that could not only split its time amongst many tasks, but forcibly take back control from any greedy program that tried to monopolize the CPU's attention. The innovation? The process scheduler. At its core, a scheduler is a referee. It juggles dozens, nowadays thousands, of tasks, giving each a slice of processing time before moving on to the next. This trickery happens so quickly, from microseconds to milliseconds, that humans see simultaneous action, much like the smooth movement in a film reel. Suddenly, a user could be composing an email, downloading a file, listening to music, all while the operating system silently kept everything running in harmony. This technical leap fundamentally rewrote how we interact with technology. Instead of waiting on computers, computers began to wait on us. Multitasking became not just a feature, but a foundation. Word processors, desktop environments, web browsers, and even the notion of having multiple windows open all trace their roots to advances in process scheduling and multitasking, first in heavy-duty Unix systems, then in Windows NT, macOS, and beyond, right into our smartphones today. Spreading first through servers and research labs, the benefits hit mainstream as personal computers became household staples. The office worker no longer had to juggle floppy disks, artists painted digital canvases while listening to CDs, developers wrote code while compiling and testing, all at once. As processors became multi-core and systems more complex, scheduling matured to distribute workloads across many CPUs and even coordinate jobs over large networks or data centers. Today, seamless multitasking is so ingrained in our digital lives we barely acknowledge it. But without those early breakthroughs in scheduling, the modern computing experience, from running background antivirus scans to toggling between video calls and spreadsheets, would remain an impossible dream. Next time you slide between apps, drag a song onto a playlist while your code compiles, or watch a video while spreadsheets recalculate in the background, thank the invisible revolutionaries who made multitasking humanity's second nature. In the hidden